So part C, the stable nuclei with a mass number greater than 20 contain more neutrons than protons. By reference to the properties of the nuclear force, right? So what are the properties of the nuclear force? Well, the nuclear force is the strong nuclear force is very short range. Okay, that's one thing I think we need to say. There's four things, right? Coulombic force, not so much, right? The repulsion or Coulombic force is not limited by distance. Right? Okay, by distance. Okay, and then think about the neutrons, right? What they're saying here is that if we make a graph of protons versus neutrons, right? That's the magic, protons equals neutrons, right? And that the elements go like this, and then at some point, stable nuclei go there, and then they just get too big, right? Okay, and what's happening is, of course, what the nucleuses are the nuclei are getting bigger, right? As they get bigger, the Coulombic force is going to start to take over, ripping the atom apart, and so the neutrons are needed to dilute that force, right? Or the neutrons add strong nuclear force without adding Coulombic repulsion. Okay. I mean, this is one of those things where they've got this whole thing, right? The electric force is repulsive, tends to split the nucleus. Electric force acts on protons. Strong nuclear force acts on nucleons, on all. Okay, that's a good argument, right? Acts on all of these things, right? The nuclear force is attractive. It binds the nucleons, right? But the electric force is long range, whereas the nuclear force is short range. We got that one. Adding more neutrons compared to protons contributes to binding, but does not add to the tendency to split nucleus. A proton repels every other proton in the nucleus, so extra neutrons are needed for binding. But there's 4 maximum marks there, so happy marking.